this. I want you to start doing these problems right now. Yes. Is it a discipline issue? He's taking care of something. Okay, no worries. Okay, let's now let me just give you guys a heads up. Don't try to write everything down. Just try to do the problems real quick. Don't worry about all the extra stuff. This is, of course, it's being live streamed. You already have copies of these notes through your onenote.com account. Would you close that door, please? You already have copies of these. This notes that we're doing right now is available through your OneNote. I'll teach you how to get into that later. I've also got page numbers for the textbook. Over the weekend, some of you, 22 of you, responded to a survey that I sent out on Remind about what you thought about the digital paperless environment. The feedback was 19 people said that they loved what we were doing. And then the other folks, their feedback was, yes, we like what you're doing, okay, but I wish I had a book, or I wish the class was tethered to a book. I wish it was something I could refer to if I wanted to dig deeper or read, because I'm a book person. Like, this was the kind of feedback I got. So I said, hey, let's do a hybrid approach. So I'm going to teach you how to get a physical copy of the textbook if you want to take one home permanently for the rest of the year. But most of you will like the second option, where I show you how to get the textbook on your phone for free, where you can download it, use our school Wi-Fi to download all the chapters of the book, and then they're locally on your phone. You don't ever have to use data or Wi-Fi to get at the book. Some of the homework for today is going to come from the book, but I've pasted it into OneNote. And then you've, of course, got the live stream that you can watch later if you get confused. Finally, 2 notes I want to make. One note is, or the first thing I'd like to say is, between now and February 20th, and actually all the way until STAR, every single day after school, Monday through Friday, I will be in this room until 4:30 p.m. as a tutor. Okay, so not as a teacher, but as a tutor. If you need help with math, you can come in here and I will help you one-on-one for free. Every night, some of you hopped on the live stream over the weekend. Every night I'll be hosting that live stream where I'll be lesson planning, but also if you have a question, you hop in that live stream and say, hey, can you help me with number 4 from page 409, or can you help me with unique ID number 112 from my Delta Math homework? And I will help you live. So that actually worked really well. Jonathan S., y'all know who I'm talking about? He and Gerardo and Matthew, Eduardo, they were all on the live stream over the weekend. And we were actually doing work, talking back and forth. It was really cool. So we're getting into that. Let's see. So we said Evan is here. Okay. No Matt. And no Austin. Okay. Yes. Sure. Can we do it at the end of class? Thanks. Now today, there's a lot to cover. I'm going to be moving fairly quickly. If you get behind on the notes, just instead of trying to struggle to write, even though or looking on someone else's, just skip a page and you'll fill it in later. Okay, Evan, just grab your math journal and you can join us. We haven't started just yet. Just flip a page and you know you can go back and get it later from the live stream. Once this live stream airs, it takes about an hour to process, and then it posts itself as a video to my channel. So you go on the YouTube channel, it'll say 5th period, Algebra 1, February 3rd, 2020. And so that's where you know. So your question earlier about what did we do last week, if we keep this up, you'll never have to ask that question because you'll be able to see it. Right now, we actually have one student who is Austin, who probably is watching this right now. Okay, we can actually see if he posted anything to live chat. No, but there are 2 concurrent viewers. See that? Okay. So I took attendance, told you guys about all that good stuff. Oh, so there are Thursday, February 20th. That's not next Thursday, but the Thursday after that. So like 2.5 weeks, we will have the huge star benchmark. This is more important than Renaissance. This is more important than the fall benchmark. This is more important than your 8th grade star test, right? So all that's in the past. This is now. So for 2.5 weeks, we are going to charge hard. We're going to be sprinting. And then we got 58 days from today until the star test on May 5th. So for the next 58 days, guys, this needs to be the one class. Like I know English as well, right? But English and algebra, that's where your heads need to be turned on. And your other teachers will probably give you a break. If you tell them, hey, I'm doing 5,000 problems in math, I need a break. 72 days until summer. That's 72 days until you are sophomores. Somebody over the live chat said this weekend, or live stream, this year has gone by really fast, and I agree. Y'all, it's almost over. We are way on the downhill slope. There were 166 days in this academic year, and we only have 72 left, so we're way past the halfway point at this point, okay? It's going to fly by. Once that star test is over, you're going to see this class change into what it looks like for the sophomores that I teach. Much more relaxed environment. First we gotta win the race, then we celebrate. Okay, let me help you do these. So first I'm going to distribute. So that's n squared minus 3n cubed. Okay, it's 3n cubed because it's n to the first times n squared, and you add the exponents for the product rule, plus 2n. And there, that's done. Now this one says factor 6m squared minus 8m. What it's saying is divide out the greatest common factor, which in this case would be 2m. Because you can divide a 2 out of both terms, and you can divide an m out of both terms. So we got 2m, open parentheses, 3m minus 8, close parentheses. And I just want to repeat this. If I move something up and you didn't get it, you got it in the live stream. You've got the OneNote, so you have copies of this. So no worries, okay? I was telling students in a previous period, note-taking is a 2-step process. First, we have the experience live right now. But it's that going back to those notes and filling in the stuff you didn't get and making it clearer, erasing something you had to just abbreviate and writing it all out, making it nice, highlighting important things. That second time is when you actually learn. Because right now, you're struggling just to write everything down. It's hard to think and write. It's that later time when you're really looking at it that you'll learn the math. Okay, so simplify 4w squared plus w plus 15w squared. The first step is to combine like terms. So this term combines with this term to be 19w squared plus w. Then we divide out the greatest common factor, which is just w. Pay close attention. Now I have a w on the outside. On the inside, I have 19w plus 1. Because w divided by w leaves 1. So that's a real important one there. All right, going up here to the second column, number 20. What we're going to do is multiply one term at a time. So 5 times 4, 20. X times x cubed, x to the fourth. Because it's x to the first times x to the third, so it's x to the 1 plus 3, which is x to the fourth. Now how about y to the first times y to the first? Y to the second, or y squared. So there it is. Hang on one second. Okay. Otherwise, anyone wearing headphones feeling, ah! Okay, so number 21. It's exactly the same as number 20. Multiply the numbers together. Negative 2 times 7? Negative 14. A to the fourth times a to the first? A to the 5. C to the fifth times c to the fourth? C9. Yeah. Good job. Finally, we're going to find the area of a square given side length 6x cubed inches. What do we know about squares and their side lengths? They're all the same. Yes, they're all the same, ladies and gentlemen. And what is the formula for area? Length times width. But the formula for the area of a square is still length times width. So you could do 6x cubed times 6x cubed. The easier way to write that is 6x cubed squared. Kind of like if the side length had been 4, well, then the area would be 4 times 4, or 4 squared. So it's exactly the same thing, only this time there's a letter in there. So now we're going to use something called the power rule. Okay, this is called the power rule. And what the power rule says to do is distribute multiply that 2 over here and over here. You're going to multiply the exponents. Now, what exponent is there for the 6? 1. Okay, that's super important. So now, here's what that looks like. It goes from being 6x cubed, the whole thing squared, to 6 squared x to the 6th power, because 2 times 3 is 6. So when you're multiplying variables together, you add the exponents. When you're taking one variable to the power of another number, you multiply the exponents. Okay, now can we simplify this at all? What is 6 squared? That's 6 times 2.
Oh, sorry.
All right. And so we write that as inches square, square inches. Okay, good warm-up. That's good. That's a good warm-up. Now we're going to learn how to add and subtract polynomials. Well, actually, right now we're just going to learn how to subtract. It says here, two rectangles are shown. What is the difference in their perimeters? What does perimeter mean? So I would start on a new page. Was that the question? Oh, I know. I need water, and there's water right here. Oops. Today's been a lot of talking for me, so my throat's starting to die. Well, how do we find the perimeter if we're only given two side lengths? Yes, sir. Leo, that's perfect. So the two long sides equal one another, two short sides equal one another. Let me show you how to write that in math language. 2, open parentheses, 3x plus 4, close parentheses. So what Leo said, they're both the same, so I'll say 2 times the long side plus 2 times the short side. What's the short side? X. So now let's distribute. And then combine like terms. Okay. Now, that's the first figure. Here's figure 2. 2 times that whole side length, 2x squared, plus 3x, plus 6, plus 2 times x. Distribute 4x, 4x squared plus 6x plus 12 plus 2x. Okay, let's identify our like terms. These two terms are like terms. They'll go together. So now we'll do 4x squared plus 8x plus 12. Everybody follow how I come up with that? All right. Now comes the fun part, subtracting them. And we're going to do two methods of subtraction. Here's the first method. I call this the stacking method. So subtract by stacking. This is going to remind you of the old school subtraction. So we're going to take the longer term. Your intuition should probably have told you take the longer term, 4x squared plus 8x plus 12, and then put a minus sign, and then put the shorter term where you're lining up the terms. So this like be 8x plus 8. And now, what you want to do, draw your line. And we're going to perform subtraction. Okay, 4x squared minus nothing is 4x squared. 8x minus 8x is nothing, 0. So just don't write anything. 12 minus 8 is positive 4. So you have to put the sign when you do this. And then that just simplifies to 4x squared plus 4. If we decided to simplify further, which this problem doesn't tell us to do, but we could divide out of 4 and rewrite this as 4 open parentheses x squared plus 1. So this and this are the same thing. One's just the simplified form of the other. 4x squared plus 4, or 4 times x squared plus 1. You're one distribution away from being right back at your original. Here's the second method. I like this method better, by the way. The second method is the way that your teachers will use later in your life. So this is subtract using distribution. And you can kind of choose which way you want unless your teacher tells you different. In this example, we're going to write 4x squared plus 8x plus 12 minus, open parentheses, that's the key, open parentheses, 8x plus 8, close parentheses. And now you're going to distribute that negative symbol. So let's write our next line. We're just going to rewrite all this. 4x squared plus 8x plus 12 minus 8x minus 8. And now we'll find like terms and combine them. Here's a like term here. And here's a like term. Okay, and then we've got these whole numbers that we'll mix. And so first we're going to write 4x squared, and then these cancel out, right? Because 8x and negative 8x, those cancel out. And now what's 12 plus negative 8? Plus 4. Well, looky-doo. It's the same thing.
Yeah, I like the other one better.
Okay? Again, it's the same thing. So one saves a little bit of space. And I got to tell you, that's the way they're going to do it in a lot of your math classes. So you're going to need to know both. But if you have the choice, you choose whichever one works best for you. Me personally, I use the left method because I used to always forget to distribute the negative symbol. I didn't remember, put those parentheses until I was basically done with school. Great. Now, here I'm going to jump up here and block this board because I don't want you to write all this stuff. Okay? What I want to teach you to do is to write a skeleton. So turn a new page. Write part C, degrees. So this is how you write a skeleton. If you see your teacher put up a huge slide like this and you know there is no way you'd be able to write all that down before he's moved on, or she, then write a skeleton. So here, I've got, you see the rule lines? You follow the same rule lines. So just write degrees, new line, indent definitions. So I would write 1.def, because I'll remember that def means definitions. So a little shorthand, okay? And then one new line, indent, A, and then I would write out constant. Leave a line. Don't write any of this. B, monomial, line. C, binomial, line. D, trinomial, line. E, and then I wouldn't write anything here. Okay? So that means your only obligation when you see this slide pop up or this screen is just to copy down that skeleton. And then you fill it in later when you go back to your notes. Now, some of you are going to be like me. Going back to the notes, that's going to be a difficult proposition, brother. So if you're going to do that, then I would write really, really fast. These are just examples on these lines here. So you don't necessarily have to write them all down. But this is the definition of a constant. Anything that is not a variable. Okay? Basically, a variable is a letter. A constant is a number. Or some... Say what? Yeah, that's what I'm saying. So now you got the skeleton down, right? And now we fill in the skeleton. Now we fill it in. So constant is anything that is not a variable. Okay, we got to know a variable means letter, like X or Y. So notice there's no letters here in these examples, but they could be anything. 5, 9.5, 7.2, pi, 3/4, 3 pi over 5, square root of 6. Those are all constant terms. Now I've highlighted mon with 1, bi goes with 2, tri goes with 3. That makes sense. So a monomial is a polynomial. Poly means many. Monomial is a polynomial with one term. Example, x, 2x squared. You say, well, wait a minute, there's two things there. Yes, but they're separated by multiplication or division. That means it's still one thing. You don't see any addition or subtraction symbols in this line. 25x squared y, 6x squared y cubed z to the 5th, 42x squared over 7y, 81x squared y cubed over 9xy. Those are all monomials. Okay, that was fun, but this is the stuff that you're going to use more often for the next 2 weeks, binomials and trinomials. Binomial is a polynomial with two unlike terms, so they cannot be combined. If you can combine like terms, you need to do that before you start thinking about binomial, trinomial. Here are some examples. X plus 1, 2x squared plus 6, 9y minus 4x, 3xy minus 6z, 5x minus 5 over z, and negative x squared plus y squared over z. All examples of binomials. Trinomials. This is getting a little bit where I'm kind of belaboring the point. It's a polynomial with three unlike terms. X plus y minus z, negative 3x squared minus 2x plus 1, 6x squared y cubed plus 4x squared plus x, or x minus y plus z over 5. All examples of trinomials. Notice there's three terms. 1, 2, 3, 1, 2, 3, 1, 2, 3. Here, this one looks weird. You say, well, that looks like a monomial. No. There's a subtraction and there's an addition. It's a trinomial. This is x over 5 minus y over 5 plus z over 5. That's how you say that. Or x minus y plus z over 5. It's three terms. Bottom line. All expressions with more than three terms, this should say are, not is just called polynomials. Okay? Are just called polynomials or many terms. And they could be infinite in number. We just don't have cool words for them. You're doing great. Okay? It will be over soon, ladies and gentlemen. Let me give you a moment to catch up on the writing. If I were you, I'd write down like maybe 2 examples. You don't have to write down all of them. And just remember, I've had to keep reminding you this. This is being recorded. You can access this later if you're having trouble keeping up, or if you're tired, or Austin, if you're listening. Last week, we tried this with one student who was out. That was the first time in history that we'd done it. It worked so well. Kennard is able to watch these from home. Makes him feel like he's in the class, you know. And I haven't checked with Austin. Can you check with Austin, see if he's actually watching? Because it would be cool. If he is watching, tell him to see if he can post something in the live chat. Who is me? Oh, that is? Okay. Here, let's say, sup, man? Yeah. So for me, this is exciting because now you don't have to worry so much about, oh, I don't remember what he said in class. You have the class. It's cool. Can I move on? All right. Whoa. Okay, better just use. Okay, so this is a new page, new section or whatever. Degrees. Okay. When you get out of high school, you get a diploma. When you go to college, if you go 2 years, you get an associate's degree. If you go 4 years, you get. If you go 6 years, you get master's. If you go 8 years, you get a doctorate. What is that called? There's 3 letters. PhD. Anyone in here want to get a PhD? All right. Yes. In math? Ah. Which one? Animal science. Does anyone want to get a real doctor? You want to be a real doctor? You'll make a lot of money doing the nurse. Chef, I don't know about money, but yeah, depends. New page. Okay, so let's start doing degrees. So the degrees of a monomial. Monomial is different than polynomial. For monomial, you just add up all the exponents of the variables. Okay, so let's take a look at example 1. There's a hidden 1 here. See that? So what's the degree of this monomial, x, y, z? X, y cubed, z to the 4th. Degree 8. So we say 8th degree or degree 8. Skip this guy here. Let's go down to B. All other polynomials. It's easier. There's no counting up involved. All other polynomials, you just take the highest exponent. So let's do these first 2. What's the degree of this one here? X squared plus 2. 2. You just say, well, what is the exponent that goes with the only variable there? See, the only variable is x. It has an exponent of 2, so this is a degree 2 equation or a degree 2 expression. Let's jump to Mr. J. J, what is the degree of this binomial right here? You just take the highest exponent. Degree 4. See, degrees are easy. I should say now, note, alert, warning. You must simplify before finding a degree. So that's why when looking at this example here, you would say, oh, this example over here on the right, you'd say that's degree 3 because I see an exponent of 3. But wait, if we simplify that, first, I can cancel out an a value from all terms, leaving me with a plus 2. And then I can cancel out 1b, leaving me with b squared. So that was actually a second degree binomial in disguise. Because you use a quotient rule. When you divide exponents, okay, here's what a little mini lesson. This is equal to b squared. Okay, because that's b to the 3rd divided by b to the 1st is b to the 3 minus 1. It's just the opposite of when you multiply and you add. When you divide, you subtract. Always write polynomials in descending order by, and this should say by exponent, by highest exponent number. By highest exponent. Constants always go at the end. Okay, so let's identify the constant here. In this example, this plus 4, it's going to go at the end. What's the highest exponent value?
3.
What's the whole thing there? 5x cubed. That goes first. What goes after 5x cubed? 3x squared. And then you say, well, which one comes next, x or y? You go in alphabetical order. So then it'll be plus x, then plus y, and then finally plus 4. So let's rewrite that in proper order. 5x cubed plus 3x squared plus x plus y plus 4. I wouldn't be showing it to you if it wasn't going to be on there. Skip this one. Okay, if you're wanting a challenge, Jay, okay, go back and look at this one later and do it. Okay, here comes the real meat of today's lecture. So what I want everyone to do is stand up for me, because this is after lunch. Do you want to know the Latin word for after a meal? Ready? You want to hear the word? You can tell people this word. Postprandial. Prandial. Postprandial. So after you eat like this, your blood sugar spikes through the roof, and then your insulin bathes that blood sugar, tries to put it down, and so we do one of these. Whoa, boom. Right about now, you're here, ready for nap time. Okay, and all you're hearing is Morelli's voice just sonorously putting you to slowly rock to sleep, right? I just want us to stand for a minute. Yes, you do. First, outer, inner, last. That's right. And Punnett squares. Okay, let's take another 30 seconds and then we sit back down. Okay, you ready? Let's sit back down. Let's get this done. We're almost done. There are 3 methods of multiplying binomials together. So this is bringing us to the quadratic stuff. This is where we're starting quadratics today, and we have to kind of build up to it. So we've built all the way up to the place where we're going to be getting quadratics now. So first is we're going to do the horizontal method. I'll do it right here. Just repeat the example. We had 2x plus 3 times x plus 5. So this isn't FOIL just yet. This is the horizontal method. Again, you get to choose, unless otherwise directed, what method you use. I personally hate this method. Okay, so first we do 2x, open parentheses, x plus 5, plus 3, open parentheses, x plus 5. And then we distribute, multiply, and simplify. So 2x times x is 2x squared plus 10x plus 3x plus 15. These terms are common, and they always will be. So 2x squared plus 13x plus 15. Okay, that's what would have happened here too. 2x squared plus 10x plus 3x plus 5. 2x squared plus 13x plus 15. Okay, here comes the FOIL method. This is, I don't like the horizontal method, even though it does come up sometimes. Let's do FOIL. By far, these two methods, FOIL and box, 99% of the time you'll use these. Okay. So we all know first, outer, inner, last. First, outer, inner, last, ladies and gentlemen. So let's actually do it. Now I use this little diagram. Once you get really good at this, you don't have to draw these pictures, but I'll show you two different pictures. Here's the first one. Oh Lord. Okay, hang on. The computer's going crazy. Here's the first picture. First terms. What's x times 3x?
3x squared.
Mm-hmm. That's first, right? How about outer? What would I multiply together for outer? No, those are last. X and 4. And this is outer. What is x times 4? Positive plus 4x. And then inner, ladies and gentlemen, negative 2 times 3x. That's inner. What's that? Negative 6x. And then finally, last. What was that, sir? Negative 2 times 4. And what is that? Okay, once again, you always combine these middle terms. So let's simplify. 3x squared. Uh-oh, now I don't know what to do. What's 4x minus 6x? Negative 2x. And then am I done? Minus 8. Okay, you have just written a quadratic expression. Congratulations. Quadratic expression. We'll talk more and more about why that's a quadratic expression. But if you want to know, Jay, Taylor, Elizabeth, Emily, Jasmine, Charlie, okay, other folks in the room, it's because of that squared term. The highest exponent is a 2. Quadratic expression. Okay, let's see what happens when we do this one. First, okay, so I was going to show the other one. So that's this one picture where there's all the lines. Now I'm going to show you Isidro's sister's method. Okay? Does everybody know who she is? Which sister am I talking about? Michelle. Okay? Michelle taught me this. So we call this the half moon method, or she called it the half moon method, and then Jade Lynn called it the claw. So let me show you what it looks like. This might be better for you. The first thing she did is draw this picture. Wait, I messed it up. Okay. You just kind of go with it. See how it kind of looks like a moon? Kind of?
Yeah.
Or a claw? So that's first, outer, inner, last. Those lines indicate what to do. Now, see, for me, this wasn't... she was a real visual person, and so that was how she remembered to do it, right? She drew the picture first, and then she did the math. I thought it was cool, because I'd never seen that before. So let's actually do it. And we're not even going to follow any particular order. Just multiply things that the lines are telling you to multiply by. How about x times 3? What's that? How about x times 2x? How about 1 times 2x? How about, what's this one? 1 times 3? Yeah. So it doesn't matter. We'll clean it up now. But she did this and she wrote it down kind of backward, you know, like this. It was all mixed up and then she fixed it. So she gathered her like terms. What does that add up to? 5x plus 2x squared plus 3. And then she brought the big term up front. So how is my final right going to look? Yeah. Nothing wrong with that, guys. So 2 different ways to do FOIL. Which way? The second way?
Yeah, those lines all over the place.
Well,
I made a rainbow.
that's why I showed you both ways. See, last year I didn't know that moon method. Now, even the moon method is really cool, but guys, you're going to love box, okay? Box is the foolproof method. Box is the easy clap method in the words of my man Brennan, okay? Let's do box method now. This is so easy. You're going to love it. Ready? Write x plus 3. Let's be colorful here. I don't want to use it. Let's use this other color. We haven't used pink. X plus 3 and x minus 4. You write it just like that. And then you make a box shape like this. And then you fill in the box. What's x times x? What's 3 times x? Okay, and then x times negative 4. 3 times negative 4. So just now write it all out. X squared plus 3x minus 4x minus 12. Combine the middle terms. Okay, so it's x squared. 3x minus 4x is negative x, or negative 1x, minus 12. There it is. Box is easy. Box is easy. And let you know, now in this homework today, I'll be telling you which method to use, but after that, I'll be encouraging you to use whichever method you find the easiest, okay? Now let's do box for this one. 2x plus 5. Then 10x and plus 6. Okay, we're going to make the box shape. Make our window. And now we're going to fill it in, ladies and gentlemen. What is 2x times 10x? 20x squared. Good job. 2x times 6? 12x. 5 times 10x. Okay, 50x. And then 5 times 6? 30. Let's write it all out. I guess I'm going to run out of space a little bit. Run out of a space. And then we'll write 20x squared plus 50x plus 12x plus 30. And then I'll write the reduced form over here. So we're going to combine like terms. What's that reduced form going to look like? $20x squared plus 62x plus 30. Awesome. That's also quadratic. You just wrote a bunch of quadratics down. Okay, they all kind of look like this. X squared minus x minus 12. And then 20x squared plus 62x plus 30. It's quadratic. This is a quadratic. 3x squared minus 2x minus 8. This is a quadratic here. 2x squared plus 5x plus 3. All quadratics. Okay, so skip, skip, skip. And we'll go right here. This is your homework for tonight. I think it's 12 problems. All you're doing is binomial multiplication. So here's the deal. You have to get access to this. This comes from page 483 of the textbook. Chapter 8, page 483. Because I'm an idiot. You're the first person to notice that all day. Wow. Thank you. Now it's foil. Foil, yeah. Wow, you're the first person to notice that all day. Thank you for being observant. Okay, guys, so how are you going to get a hold of this? OneNote.com, you log in with your Westwood email, you can get this whole thing. OneNote. Oh, you get it through OG Math, okay? OneNote. Okay? You also could go to the library and check out a physical textbook and just go to page 483. All right, we need that button. That was easy. Or, and this is the preferred method, access that digital textbook for free at connected.mcgraw-hill.com, or preference by downloading the Connected McGraw-Hill app on your phone so you always have a copy of the book with you. Many of you did this last semester when I told you to. You have an account already, and that account would be like whatever your login is. Okay, just the first initial, last initial lunch code, and the password is Panther 2019 exclamation point. It's the same password we use for everything. So here's that connected app. Open it up. And then you choose your book. Click on the book and go to chapter 8. Look how easy this is. It opens up. Right? So now you're going to go find page 483. Yeah. There it is. I have a video on Athenian Stranger. If you want to write down this URL, https://tinyurl.com/free algebook. How to get the Algebra 1 textbook on your phone for free. Not clickbait. All right? And there it is. But for today, I know people, it takes people a couple days to kind of get on board with what they need to do. For today, I'm seeing people writing this. Can I move? For today, I'll just show. Uh-oh, it froze. Oh dear, please tell me it didn't freeze. It's going to go blue screen. Please, no. All right. For today, you can just take a picture with your phone or just copy it all down in your math notebook and go home and do it. All right. It says here, for the odds, I want you to use FOIL. For the evens, I want you to use box. And yes, you have to do number 24. It isn't that hard. Yeah, you got 10 minutes if you want to just get started on it. Fifth period is so lucky because y'all have that extra 10 minutes. I can slow down a little bit. Evens box. Just do it right in your math journal. Right in your math journal. What? Odds will be like 13, 15, 17, 19, 21, 23. Evens would be Can you look? Read it. Read it. Write each product as a quadratic expression in descending order by degree. Hey, hold up. Hold up. Let me finish. I will be online tonight. Sometime, guys, between 7 and 8 or 6:30 and 9. I don't know, guys. Somewhere in there, whenever I can get home and get out, get settled down and eat some healthy Chef Boyardee or ramen noodles, and then, like drink a vat of coffee with the ramen, because that's good for you at late at night to drink much coffee.
You know what I learned about ramen?
What'd you learn?
It's like so processed that ants won't even eat it.
Ants will not even eat the food that I consider to be my staple diet. I still have some tamales from Friday, so I might eat some of those. And I got that summer sausage that FFA sold me. I didn't collect it today. What? Yeah, page 483 of the textbook. See, here's the instructions right up above it. Hey, you guys did great today. This was kind of the hardest day we've had in a long time, right? There's a lot of talking, a lot of writing. Hands are cramping, but you guys did great. Just do your work in the notebook. Yes, sir. So, either take a picture of it, Jay, or write them all down. Your Westwood, the prefix, so whatever it would be, TS, lunch code, that's it. Not at Westwood. And then in the password, it's capital P, lowercase a, N-T-H-E-R, 2019, exclamation point. Here's the good news. If you download that textbook on our school Wi-Fi, it's on your phone, and you don't have to be connected to data or Wi-Fi to get on in the future. If you want a physical book, you go to the library, okay? Page 483. 483. Chapter 8, page 483. Oh, yeah. Yeah, I'm still recording. You're all right. What's wrong with so what? This is our class. Yeah. You're not. The only thing being recorded is my screen. Yeah. Now that's a webcam, but it's facing the wall. Oh yeah. Okay, I will suspend the live stream at this point. I want to thank all of our millions of viewers for watching. Please check out our merch store and donate to me on Patreon. Thanks, guys.